Let's now start the set of exam questions for lesson 3 on coordinate geometry, pure 1. The first question is this one. This is paper 1 from November, let me see, October-November 2007. Question 6. You are given this diagram and you are told that 3 points A, B, and C, and you have the coordinate for the 3 of them, are shown in the diagram, and point D is such that the line DA is perpendicular to AB and DC is parallel to AB. You want to get the coordinates of D. Okay, so you are given the coordinates of 3 points. This point apparently doesn't have anything to do with these 3, so you need to get the relationship that will start from this and will allow you to get into that. Okay, what is this point? You can think of this point D as the point of intersection of this line and this line, right? But you are not given any information, at least directly, about this line, nor this one. About this one, you just have 1 point. About this one, you also have just 1 point. What you have plenty is information about this line. So how can we get from the information that you are given about this line to the information that you want to get, which is the coordinate of that point? Well, think of this line first. This line is perpendicular to this one. So if you can get the gradient of this one, you immediately or almost immediately get the gradient of that one. In order for you to get the full equation of that line, you need a point that belongs to that line, and you have one, it's point A. So now you already have a way to get the equation of this line. Don't forget that for you to get the point of intersection of 2 lines, you need to have beforehand the equation of those 2 lines. And you already have a way to get the equation of AD. We need to get now the equation of DC. So how do we get the equation of this line? We know that this line is parallel to this, so we already know the gradient. In order for us to get the full equation, we need to know a point that belongs to this line. Do we have one? Yes, we do. It's here. So now we also have the equation of this line. So we have the equation of both lines. How we get that point? We equal one to the other, right? Equal one to the other, and we will get the x coordinate of D. Once we get that, plug that value into either this one or that equation, and you get the y coordinate. So here you have the strategy to solve this. Again, in a nutshell, get equation of this one because it's perpendicular, use this point to get it. Get the equation of this one because it's parallel to this one. You have this point to get it. Once you have both, do simultaneous equations or equal one to the other to get the coordinates of D. Right? So this is what we did. It's over here. First, get the gradient of AB. It's -2. So the gradient of that one is going to be, here I did the, I don't think it's required. Yeah, I wrote it here. Not required. Already got the y-intercept of AB as well, but it's not required for the question. So I got actually the equation of that line first. Using point C, I can get the y-intercept is 22. I obviously use the gradient the same as this one, -2. So now I have the equation of DC. I got the gradient of AD is -1 over that, so 1/2. I used point A to get the value of the y-intercept, and here I have the full equation. In order for me to get the point D, which is the point of intersection of AD and CD, I equal one to the other. I solve it, and I have a value of x of 6.2. Then I substitute it in one of those. Which one was it? I used this one, and I got the value of y of 9.6. So the coordinates of point D are the x coordinate 6.2, the y coordinate 9.6. I think it was it for this question. Yes. And 7 points for that. Once you start realizing that these questions are more or less all the same, you will start thinking of these as kind of 3 points, because there's only so much imagination can go to assess you on your knowledge of application of all these tools regarding coordinate geometry. Let's see another example. This one is from May-June 2008. It's a paper one. Paper one in question 11. So it says, in the diagram, the points A and C lie on the x and y, no, sorry, A and C lie on the y and the x and y axis respectively. And the equation of AC is 2y plus x equals 16. So you have the equation of this line. The point B has coordinates 2, 2. You have a point B with these coordinates 2, 2. The perpendicular from B to AC meets AC at the point X. First question, you have to find the coordinates of X. How are you going to find the coordinates of this line? Again, what is this point? This is the point of intersection of this line with this one. So again, in order for you to get the coordinates of a point of intersection, you need to have beforehand the equation of this line and the equation of that line. You already have the equation of this one. It's over here. How do you get the equation of this one? You need to use the fact that this line is perpendicular to this one. So you know the gradient, or you can work out very easily the gradient of this line. You know that this one is going to be minus 1 over that. In order for you to have the full equation, you need to know the coordinates of a point that belongs to this line. And you do. It's point P. So now you have the coordinates of this line. You already had the coordinates of this line. Equal one to the other. You have the x coordinate of point X. Substitute it on either this equation or that one that you are going to get, and you'll get the y coordinate of point X. Then the point D is such that the quadrilateral, we'll go to this question after. Let's just get the information that we need so far. This blue part regards the next questions. So we first got the equation of line BX. I just worked out this equation to put it in a form y equals mx plus c, so that m is obvious. It's going to be, once I do that, I know that the gradient is minus 1/2. So the gradient of this line over here is going to be minus 1 over that, which is just 2. Sorry. So using point B to 2, I can get the information about the y-intercept is minus 2. And now I know the full equation of line BX is y equals 2x minus 2. To get the coordinates of point X, I need to know that it is a point of intersection of these two lines. And I know the equation of both. CA is going to be that. And BX is the one that we just got. Equal one to the other. And eventually, we'll have the value of X, the X coordinate of point X, as being 4. Substitute it in one of those, on this one or that one, and you'll get the value of Y as being 6. So here you have the coordinates of point X is 4, 6. Let's look at the second part of the question. So the point D is such that the quadrilateral ABCD has AC as a line of symmetry. Find the coordinates of D. So what does this mean? The point D is not represented there. Is such that the quadrilateral ABCD has AC as a line of symmetry. So if AC is a line of symmetry of a quadrilateral, the rest of the quadrilateral is going to be somewhere over here, and this point D is going to be such that this will mirror this part over here. So obviously the point D is going to be somewhere over here. And I just zoomed in. is going to be somewhere over here. The quadrilateral is going to be this. It's going to be a kite. You need to get the coordinates of that. I already made a sketch of that. That's what I had over here. All right. And you need to get the coordinates of point D. How are you going to get the coordinates of point D? You have a very simple technique that will allow you to do this. What is this technique? You have to think that in terms of, you haven't studied this yet, at least with the detail that will require for this to be completely obvious. But if you think of it a little bit, it is anyway. What is the relationship between B and X and D? Knowing that this is a line of symmetry. Think first on the x-axis. Imagine here the coordinate of point B is 2, the x-coordinate of point B is 2, the x-coordinate of point X, we already got that, it was 4. And what do you think the x-coordinate of point B is going to be? If this line AC divides this quadrilateral into 2 equal parts, if they are symmetric, so this distance over here should be the same as that one over there, right? So what was the amount by which the x-coordinate increased from B to X? It went from 2 to 4. So the level of increase from X to the x-coordinate of X to the x-coordinate of D should be the same. So if this is 4, the x-coordinate of D should be 4 plus 2, which is 6. And you use the same method for D. How much did the y-coordinate increase from B to X? It went from 2 to 6. So it went up by 4. The level of increase should be the same over here. So in X is already 6. 6 plus 4 is 10. See what I did? You can imagine here these little 2 triangles, which are exactly the same. This increase is this increase. That increase over here is the same as over there. How do you represent this mathematically? You put it in terms of vectors. You know that point X minus B needs to be the same as D minus X. So point D, the one that you want, is going to be, if you work this out, 2x minus b. Don't forget that these are the points themselves. If you then substitute the points by their coordinates, what does this mean? 2x, x is 4, 6. So 2x is going to be 2 times 4 and 2 times 6. Minus b, and what was b? It was 2, 2. All right? So you are just multiplying this coefficient over here by the coordinates of x, which were, again, 4, 6. So this will become 8, 12 minus 2, 2. Once you get used to operate with vectors, this will become obvious. You can only subtract the x's and the y's. So what is the x coordinate of x is 2. So this is going to be 8 minus 2. And this is going to be 12 minus the other 2 for the y-axis. And the coordinates of D is 6, 10. This way you very neatly represent all the information that is required for you to get what you want. Next one and last one is find, correct one decimal place, the perimeter of this quadrilateral. The perimeter of this. So it should be obvious to you that this distance DA is the same as AB, and CD is the same as CB. So once you know this distance, you just multiply by 2 to get this part over here. Once you know this distance, you just multiply by 2 and you get this part over here. Then add the whole thing together. That's what was done over here. First, the distance BC equals the distance CD, and BA equals DA. You need to write this down to prove what you are doing eventually when you double the values. Let's get the we first needed to get, we didn't have them yet, the values of C and A for the line AC over here. Where is it? For the line AC over here, we already had the equation, is this one. When x equals 0, we will get the y-intercept, and y equals 8. When y equals 0, we will get the x-intercept, so, which is 16. So the y-intercept is 0, 8, has coordinate 0, 8, and the x-intercept has coordinate 16, 0. We are talking about these 2 points over here. Now that we know the coordinates of the points, which we didn't until now, we can get very easily these distances by just applying the formula. So BC over here, just apply the formula and you'll get this value, square root of 40. Distance BA over here, just apply the formula for points B and A and you'll get this value over here, square root of 200. So the perimeter is going to be 2 times this plus 2 times this. Plug in on a calculator, correct to 3 significant figures, the value is 40.1. Another question, this one from May, June 2009, paper 1, question 8. It says this. The diagram shows points A, B, and C lying on the line 2y equals x plus 4. A, B, and C lying on this line over here. The point A lies on the y-axis, and AB equals BC. The line from D, 10 minus 3, to B is perpendicular to AC. Calculate the coordinates of B. Now the words B is what? B is the midpoint of AC, right? And you want to get the coordinates of that. Again, is the midpoint and also is a line of intersection of two, a point of intersection of two lines. Lines AC and line BC. You already have the equation of line AC. And again, what you need to get the coordinates of a point of intersection, you need, first of all, the equation of the two lines. You already have this one, you need to get this one. How do you get it? Well, you know that this is a perpendicular line to that one. So first you need to know that the gradient of this one is minus 1 over the gradient of that one. And you can very easily from this equation get the gradient of that one. In order for you to get the full equation, you need to know a point belonging to this line, which you do. It's this. So now you are going to have the equation of this line. You already had the equation of this one. Equal one to the other or your simultaneous equations. And you will get the coordinates of point B. And that's how you get 7 points. Let's see. So here you have the equation of line ABC. I just put it in terms of the y equals mx plus c to get the gradient is 1/2. I can get also the coordinate of point A by substituting x by 0, and I'll get, yeah, of course, I already knew that from over here. This is the y-intercept, so that is the coordinate of point A, which is the y-intercept of the line. For line BD, I get the gradient as minus 2. It's minus 1 over that, so it's minus 2. Using this point, I can get the value of the y-intercept, which is 17. So now I know the equation of line BD. It's over here. If B is the point of intersection of AB and BC, so we equal one to the other, and we'll get, and we solve it, and we'll get the value of x equals 6. Substitute it in either one of those, and you get the value of y is 5. So here you have the equation of line of point B. What about the coordinates of point C over here? You will use a similar approach as I used a little while ago, because if these two sides of the line are equal, you know that the distance BA is the same as BC, right? And this is true in the x direction and the y direction as well. The increase in x over here is the same as the increase in x over here. The increase in height over here is the same as the increase in height over here. See? That's why I got the equation of the coordinates of point A in the beginning a little while ago. Writing it down in terms of points, you know that B minus A equals C minus B. B minus A equals C minus B. Or point C, what you want is to B minus A. So now just substitute here the coordinates of point B and here the coordinates of point A. This will become 12, 10. Then subtract for the x 0 and for the y 2. And there you have the coordinates of point C, 12, 8. And there you have it. 7 points for this type of question.